Our next speaker is Leo Deshevsky from the Gotthard Lab at the Fred Hutch, and he'll be talking about creating interactive and reproducible R reports using Labkey, Rserve, and Knitr.
Good morning. So what's the motivation behind my talk? There's an organization called HIPSI, which stands for Human Immunology Project Consortium. And what it is a set of centers that generate massive amounts of data across various populations and assays. And the purpose is to describe the state of immune system both under normal conditions and when stimulated. So to tackle this big data problem, we use the Labkey web server for its excellent data management capabilities, as well as leverage the open source programming language, statistical language R. So there are actually two parts to this equation. The first being finding the data that you need. So you might want to narrow down to a particular assay or specify some demographic characteristics or certain treatment. And we have an excellent tool that Labkey helped us develop called Data Finder. If you're interested to learn more, come talk to me about that. I'll focus on the second part of this equation, which is once suppose you already have that data, how do you meaningfully summarize it, present it, analyze it? So I'll jump straight into the technologies that we rely on. First, there's the generic JavaScript API to communicate with an R session. So before this was available, I'd say it was really clumsy. There's a web part within Labkey, and you would pass in very limited parameters to the backend, and then you generate some limited HTML or a plot. This was inconvenient because you couldn't really pass complex data from the front end. I had to rely on like concatenating an array and then passing it as a string and then tokenizing it. Imagine with arbitrary data, your token is going to be part of the data. Things go wrong. And then even worse, you couldn't really pass any data from the R session, which we really wanted. I don't remember, I think it was Josh who suggested a hack where you pass back some hidden HTML and then examine it with your JavaScript code to extract this data that you needed. So along came the Labkey Report Execute API, and that allows arbitrary data encoded as JSON sent to the backend, and then moreover from the backend we can get text, be it JSON or HTML or console or error output or URL to generated content. The second piece of technology we rely on is Rserve. So again, I'll describe how things were before that came along. So before that, you had to have your R instance installed alongside your Labkey web server on that same machine. And basically, whenever a module required R computations to be performed, a fresh R session was being fired up, computations were made, and then it would be scrapped, the session. So you can see how that's not really efficient. Rserve is distributed as an R package. So what it allows us to do is the following. First, you can have a dedicated R machine, basically, which you can configure all you want without affecting the Labkey web server. Secondly, imagine you have your UI, which kicks off an R script, which loads some R packages, and then it loads some data from database or from disk, and then you just would like to generate a simple plot of some kind. And then shortly after, you decide to generate a different kind of plot with that same data. Well, with Rserve, it's persistent session. You don't have to reload the packages. You don't have to reload the data. It's already there in memory. Makes things way more responsive, way more interactive. And finally, the mechanism, the way it's set up currently is we're able to bind to each module its dedicated R session. And that way, if a user opens a whole bunch of copies of the same module, you're not breeding, multiple copies of R sessions. So that's a good thing. Now I'll talk about the Rlabkey and Immune Space R packages. Rlabkey is an R package that was developed by Labkey and is being maintained by them. It just allows access to Labkey database from an R session. And immune space R is a thin wrapper around that, which is dedicated specifically to immune space database. And it basically hides, Rlabkey functionality that otherwise would be redundant dealing with immune space. And it just creates a more object-oriented paradigm for accessing study data sets in kind of, better way. Finally, Knitr. Knitr is a dynamic report generation engine. It's made out of two parts. There is a markup language which kind of describes your layout and your static content. And then there's the computational engine, which in our case is R. And that generates dynamic content that depends on data. We use Markdown, by the way, as the markup language. It's really simple and easy to read and write. And Knitr generates your HTML-based output, has efficient caching mechanisms, and fine control over the way things are laid out exactly and displayed. So picture's worth 1,000 words, so I'll review what I just talked about. I talked about the execute API, which goes from the client browser to the Rserve and back. I talked about Rserve being on its own dedicated machine, usually co-located with the data, because most of the I/O, happens when you read large data files back and forth. Rserve allows for binding of module to a session. Then I talked about the immune space R and Rlabkey for accessing the database. And then Knitr, just a really powerful way to generate your output in Rserve and send it back to the UI. So I'll do a little demo. So this is a custom file-based module. This is pretty much what I mean by reproducible R report. So this is the simple, most one in terms of UI. So it's already tied to a NAR session. And you select your inputs. So here's where the output is generated. So first time around, you're maybe loading lots of, maybe I already did it earlier, that's why it didn't take so long. But if I was to run it for the very first time, it was loading for a while, data and packages and such. Second time, not so long. So this is all generated on the R side, whatever you see within this window. You can have interactive tables and very powerful summary graphics. And speaking of reproducibility, we're also thinking about how to share it. So currently we kind of rely on encoding the inputs and sharing a link. So I think we'll take up the tiny URL approach. That might be helpful because this is too long. And that's it. Come see me if you have questions or you want to discuss more of this.